I would like to start this talk from saying thank you to all organizers, and I would also like to thank all the speakers and the participants, because it's very important to appreciate what we have, especially during these hard times. And I just encourage you to be grateful, to try to find positive, and of course, let's have fun together today. So a couple of words about me. My name is Taras. I write a lot of code. You already heard that I work for Global Logic as Java consultant, but also I teach others, and I'm very passionate about education, so passionate that I eventually started my own company, and we provide high quality education for Java engineers. Also, my big passion is mountains. I do some videos and upload them on YouTube. I like reading books, and also I love our country. But the thing I am most proud of is, of course, my family. Here's a cute picture of 3 of us. And the last thing you probably should know about me is that I'm a very open person, and I would like to talk to you. It's unfortunately that we cannot see each other. At least I can't see you. But it would be nice to talk after this session. If you have any kind of questions, or if you have similar interests, just reach out to me so we can chat later. Our agenda for today is pretty simple. We will discuss briefly the ORM idea, and then we'll have the Hibernate coding session and the Spring Data JDBC coding session, and then we'll have the conclusion. So the main idea is to get the Hibernate, dive into its internals so you can understand how it works under the hood, and you can understand what kind of issues it has, and then compare it to something completely new and different. Well, you cannot say it's new, but Hibernate is almost 20 years old, while Spring Data JDBC is about 2 years old. So it's pretty new comparing to Hibernate. And we're going to start from this idea ORM, which I know you're familiar with, but we will briefly talk about it because it's very important to understand the ORM idea in order to understand how the Hibernate works. So basically, the idea is simple, and it comes from the problem. We build enterprise apps using Java, and we store our data in the relational databases, mostly, even right now in 2020. I know some of you or most of you like NoSQL databases, but for the enterprise Java world, and basically for the whole enterprise world, the standard and the default database option is still the relational database. So we store the data in relational databases, and we operate with those data as with objects in our applications, and we should map between those 2 different models. If we want to simplify that completely, then we can say that some object is linked to a database row in a certain table, and every change of the state of that object should be somehow transformed into a SQL query that will reflect those changes on the database. So as a developer, as a lazy developer, if you want to say that, I don't want to deal with SQL statements and databases. I just want to work with objects. I want to store objects, read objects, remove objects, and update objects. And I don't care about that. And this is the idea behind the ORM, and this is the idea behind the Hibernate. So we will try to think about the Hibernate in real world, like real enterprise Java application. And if you're building enterprise Java application nowadays, I hope you come up with something like Spring. And for sure, in Spring ecosystem, you will come up with something like Spring Boot, which is our best friend. And Spring Boot gives you a lot of starters. And when you want to use a relational database, most probably you will use Spring Data JPA, which by default comes with Hibernate. So this is the typical stack, and we will try to build an application using this stack first, and we will try to think about our day-to-day work, how we use Hibernate with Spring, what kind of challenges we have. We'll try to build something more or less like in real world. So let's check out the code. we're gonna start from start.spring.io. This is the Spring Initializer. I guess you already know that, and most probably you use that. So we will use this initializer to create a project with all the technologies I just described. So we're going to use the new version of Spring Boot, and let's write the proper package for this. So we're at Java Fast, and this is the Java Fast, let's say demo, and we're not going to use the Java 8, let's use Java 11. I just didn't try all this stuff with 14 version, so, and we'll add the JPA starter. We'll add H2 database so we can use the in-memory database. We'll also add the web module because we want to create something more or less real world. So we'll build some endpoints. Also, we'll need a Lombok. At this point, I would ask like, who likes Lombok? And you would raise your hand, but anyway. So, and also I would like to have the Flyway database migration tool so I can write some SQL scripts and then run them automatically by Flyway. I guess we're more or less good, and Spring Initializer will create a project that is set up for success. So let's move forward with that. I will unpack this thing using the unzip, and then I'm gonna run this using IDE. So this is the first coding session dedicated to Hibernate. But instead of just working with pure Hibernate, we will use all the other stuff that you basically use on top of Hibernate in your day-to-day job. And then let's try to figure out how it's all working under the hood. So we have this project. I'm going to use the presentation mode for this. We have this project generated by Spring Initializer, where we have only Spring Boot application and empty test, which we don't need. So let's try to build and then run this project. Hope it's working, yes. So we're gonna use the Hibernate, and we're gonna frequently check what kind of SQL queries it generates. So we want to set this show SQL to true. And also, I don't want to run any Flyway migration scripts right now, so I'm going to disable the Flyway. And that's it. Let's right now add the first entity so we can start working with Hibernate. Okay. I guess some shortcuts don't work. So we're going to create an entity called person. It's a regular JPA or Hibernate entity with some kind of fields. Like we will have, of course, the ID. We'll have the, for instance, first name and the last name, and the email. Okay, and this is the data class basically, and it's an entity. Sorry. And in JPA and Hibernate, every entity has to have a ID, and this ID will be generated by, you can say, you can specify the strategy. We'll use the identity, and identity means that it will use the auto increment database column. Also, I want to say that this column is unique, should be unique, and it should not be nullable, false. Okay, so we can run our application right now and check what is going on there. So it's working, and as you can see, it creates the table person with all of the things we specified. So now we have the entity, and in Spring Data is kind of an umbrella project for all data, different kind of data access layers. And in this particular case, we're using Data JDBC, but in general, as you probably know, in Spring Data, we use this term called repository. So we're going to add the repository for the person. It's an interface. Let's call it person repository. And it extends the CRUD repository that is built by Spring. So you just specify the person as a type of your entity and then long as type of your primary key. And you can use the method that were built by Spring Data team in this CRUD repository. So we can now, for instance, add a controller and build a new endpoint so we can expose our entities and build some kind of operations for that. And it will be person repository. Well, no, it'll be person controller. Yep. So this is a REST controller with the request mapping person. And we'll use the person repository to access the data. So Spring will inject this repository. So at the first example, let's build a simple endpoints and returns all the entities. And it will be get endpoint. So we can rerun the app, and then we'll be able to hit this endpoint and see if it's working. So the app works, and now I'm going to create an HTTP request. And a new version of IDE, as you can see, it has very nice auto-completion. So it knows that I have this person endpoint, and I can call it. And as you see, it returns the empty response. So far, it's not very interesting, but we build the ground for our next and following examples. And what I want to do right now is to add some data to the database so we can see that it's really working. I'm going to create a config class for that, and I will add the test data config, which will be the Spring configuration. I'm going to inject the repository here. And what I want to do is when the application started, I just want to generate a couple of person records and store them to the database. So I'm going to use the initializing bin. And when everything is set, I'm going to generate and store some records. So here, let's build a method that generates person. In order to do that, I'm going to use, I'm not sure if you're familiar with it, this library called jfairy. And I'm going to refresh the Maven. So jfairy allows me to generate nice data. Fairy create. And then person basically generates a random person with nice data. So I'm going to use this to... I'm going to use this generated data in order to create our the object of our entity. And once the record is generated, I can say that I want to generate stream of persons limited, for instance, to 5 objects, and for each I'm going to call the repository safe. So this should generate five new records for us. And starting from that, we can basically dive into Hibernate features because we have data and everything is set up. Let's try to call that endpoint. So as you can see, we have some entities there. And the first thing we want to do is, for instance, we want to add a new endpoint that will change something, change the state of the existing object. For instance, we're going to call it update email, for instance. We will pass the ID, the person ID, and we're going to pass the string, which is new email. It will be a super simple version of the put endpoint. It's going to accept the ID, which is pass variable. And of course, it's going to use, it will be request param new email. At this point, I would also like to ask you how many of you use Spring, and I guess most of you would raise your hand because right now Spring is very popular and you cannot think about Java backend without Spring. And I hope you like Spring because it's like heavily involved in our session. But I also assume that if you decided to watch this talk that has Spring Data JDBC in its title, then you should probably be interested in Spring ecosystem. And I guess we're good. So here, let's build a service class for that. And in this service class, we'll create the person service, which is a regular service as we usually do. Well, let's start from this. We'll add this method, which is update email, and it gets person ID and string new email. And it also has the person repository. How would you implement this method? So for sure, you're going to use the repository to find this person, or else, let's say, throw exception. And you have this person object. And then, as the ORM idea, according to the ORM idea, I would like to change the state of the object, and that's it. So I'm going to change the state of the object, and I'm going to set email, new email. And here in the controller, I'm going to reuse the service method, person service. And I'm going to call the update email, pathing new ID and email. And I'm going to rerun this thing. Who think that it's going to work? And why you think it's not going to work? So let's clear this. And let's create another HTTP request, which is put using HTTP localhost person ID. We're going to use, let's use this guy, Brandon Boychuk. So we're going to pass the ID, and then we're passing the put parameter as a request parameter. So we have to say the content type is, let's say, form, and we're saying new email equals, how was the name of that guy? Brandon. let's say Brandon at javafest.com UA. Cool. The response is empty, so it's successful, but as we can see here, we select the person and then nothing changed. So if you will call the get endpoint again, you'll see that Brandon is still at gmail.com. And it's not working, so the RAM ID is not working and everything screwed up. And why it's not working? We can fix this, first of all. Or even, let's try to do this. We can fix this by putting the transactional annotation, and it's gonna work. And probably some of you knows that you have the intuitive thoughts like we have to put a transaction on that method if we want to change something. But our goal is to dive into the Hibernate internals and understand how that transactional annotation actually, what does it change in this particular case. So let's try to call that endpoint again. The response is still successful, and then you can see that Brandon is now at javafest.com. So it's working. And this transactional annotation is provided by Spring, but what it does, it under the hood still uses the Hibernate implementation. And this, as you can see in the logs, this update statement was triggered not by Spring but by Hibernate. So our goal is to understand why Hibernate triggered this update state in this case and why it didn't trigger this update statement in that case. But before doing that, we're going to check out some additional examples, and then we'll dive into the source code of the Hibernate. So let's say we want to add a new entity. Let's call it node. So we'll have a node with the private string text and let's say local datetime created at. So this is the entity and a data class, and of course it should have an ID if it's Hibernate, and we're gonna generate the value for the ID using again the auto increment column. So this node is related to a person, right? So we say that it's many to one because you want to have many nodes for one person, and it's connected to the person using the join column that is called person ID, for instance. And we want to add additional mapping on this side. So we want to say that we have a list of nodes. Let's call them nodes. And this list of nodes and this list of nodes is one to many, but it's mapped on the other side, and the name of the field is person. So we say that it's mapped by this field. Here it's mapped. And this allows us to add nodes to the person record. And we're gonna use this, and also we want to add this JSON back reference. So whenever we use and expose the record that has some nodes via the HTTP endpoint, so the Spring started to creating the JSON version of it, and it doesn't go like into the infinite loop trying to create the JSON fields. So basically this is it. We can use the node and we're gonna add a new endpoint, and let's call it add node. So we'll pass the person ID, and we'll pass the let's pass the whole node object, and it will be in request body. So this is the post HTTP method. It accepts ID and nodes. And here we're gonna build this method called add node. ID. They should call the type lond. It would be easier for me. So I'm gonna load this person from the database, and then I wanna add a node to it. So here I should create this method add node that accepts node. And if you're familiar with Hibernate, then you know that person this, and then nodes add person, node. We'll use the person add node, and we'll pass, let's create a new node, again. We'll just pass the node here, okay? I guess it should work, right? So, and again, like, how many of you think that this will just work? Again, according to the ORM idea, if you want to change something, you should change the object. You should change the object state. So here I have my object person, and I'm passing a new node. And I'm adding this node to the person. And in the ideal world, I'm assuming that it should just work. So I'm going to rerun the app, and I'm going to use, well, I have to use it first here. I'm going to rerun the app again, and then I'm going to pass the new node, and we'll try to add it to a person. Let's clear this up. So say post to the HTTP localhost.person.id nodes. Let's use the first person, and the content is application JSON, and we're gonna pass the node that says it's not gonna work. Haha. Oh my gosh, I didn't use the port. Okay, so the response is still good, but at the application log, you'll see that we selected that person, but then again, nothing changed. So we still have our transaction annotation here, but it's not working. And of course, we can fix this if we know how to do this. I can fix this by adding the cascade type persist, and then rerun this app again. And then call that endpoint again. And then call this endpoint again. And you'll see that it says that the first person has this node. Actually, it's working. Haha. So again, in order to do this, and in order to make Hibernate doing this insert, we have to do some kind of tricky stuff like enabling the cascade type persist on this particular field. And what is also interesting and what have changed is that, as you can see here, when you hit the get endpoint, it first calls the Hibernate select statement to select all the persons, and then it triggers 5 new select statements to select nodes. We can change this, and in the config, say, let's say we have not 5, but like 100. No, let's start from 100. 100 persons in our database. And now I'm gonna call the same get endpoint to fetch my persons. And again, as you can see in the logs, we have one select statement to select all the persons, and then we have 100 select statements to select all the nodes. And this problem is called n+1 select problem. And basically, it's caused by Hibernate lazy loading, which is one of the topics we should talk about today. Hibernate lazy loading is basically enabled by default, and you cannot get rid of lazy loading. You can use either eager loading, you can prefetch the data, or you can rely on lazy loading. But it's still there because Hibernate tries to implement the idea of ORM. And according to the idea of ORM, if your objects, so if your database stores record and they are somehow connected, if the data is connected, then the data should be connected the same way in your objects. And for instance, if a person has nodes, then when I call person get nodes, then it should return the nodes. And Hibernate, in order to do that, Hibernate creates its own implementation of the collections. And whenever we use the list and say array list, in real world, it's not going to be the array list. It's going to be the Hibernate implementation of the list interface, because Hibernate needs to have an ability to call the database and fetch the list of nodes whenever you call the get nodes. And this is done using this special implementation of the collection, and this is called lazy loading. And basically it's working here because of the Spring Boot making it much easier. But if you will use, or if you are using the older version of Spring Boot, you don't have there this thing called open session in view. And we can try to disable it here. We're gonna set it to false and rerun the app. And we're gonna call the same endpoint again, and it will cause a so famous exception, a lazy initialization exception. As you can see, could not initialize proxy, no session. So we're gonna stop here because we really don't have much time on that. And most of the thing we are talking about right now, I guess you already know about that, or you saw that, or you had this kind of issues. So let's go and try to understand how it's all working. So basically, we should start from the super simple, from this config where we call the save. When you go to implementation of the save, you'll see that in the Spring data class, it's checking if the entity is new, then it calls persist. Otherwise, it calls merge. This is the entity manager. The entity manager is the JPA interface. JPA is the specification. Hibernate implements the JPA. So in JPA, we have entity manager. In Hibernate, we have session. And you can try to go and find out how it's all implemented by, I can save some time and find the default persist event listener. On persist, this method is called when you try to persist something. And it's very beautiful method. And here, at some point, you're going to see that it's checking the entity state. And the most important thing about the Hibernate at first is that each Hibernate entity has a state, and that state is somehow managed by session, and all the work Hibernate is doing it's doing in the scope of a session. And there is this class, stateful persistence context, which is basically all the brain that stores all the information about our Hibernate entities. As you can see here, a bunch of different things are stored in the Hibernate persistence context. And its documentation, it says that it's one-to-one relation between a session and persistence context. So the most important part here is that Hibernate uses sessions. So every time you want to work with Hibernate, you need a session. And in this particular example, whenever you use Spring Data and Spring Boot, you use Spring Transaction Manager, and that Transaction Manager is managing your sessions. So Spring is creating a session for you, and in those places where you need, it's using the session. It's actually using the thread local, so basically a session is associated to the user that is making, for instance, a web request. This little thing called Entity Manager in View is a feature of a Spring Boot that basically creates a session for you whenever you have a web request, and then it closes the session when the web request is closed. So most people assume that the transaction annotation represents the boundary of the session. So if you put the transaction annotation, then you have the session. In those places where you're out of the transaction annotation scope, you don't have session. But because of this entity manager in View that is implemented by special interceptor, you have the session basically during the whole web request. And because of that, in this particular case, we get all the persons using one select, but then when Spring starts to create in the JSON, it tries to access the field nodes, which is lazy, which is not initialized yet, and it still has the session because the web request is not closed, and it goes to the database. So basically, all this information that is stored in the persistence context, all this information lives in your application during the whole web request if you're using one of the new versions of Spring Boot. And what's important here is also that whenever you call the persist, for instance, whenever you call the persist, you may think that persist will trigger a insert statement, but it won't. If you'll go here, you'll see that persist fires an event. So you should understand that in Hibernate, it's not straightforward. Whenever you call persist or remove, it's not going to trigger a SQL statement. It's going to fire an event. And this mechanism is completely different from what most people expect it should be. We can go back to the presentation and discuss it a little bit. So the most important part of the Hibernate is that you should know the session boundaries. Regardless of you're using Spring Boot or Spring or you're using anything else with Hibernate, you should always keep track of the session. You should understand where you create the session, where it's closed, because session gets everything and all the feature of the Hibernate is working within the session. Like first level cache, lazy loading, dirty checking, orphan removal, and other stuff, they all will work, but if you have a session. If the session is closed, none of them will work. And if you have an event, like if you call the persist, it fires an event. That event is eventually handled by some listener, and the listener does not trigger the SQL statement. It creates an action, like persist action or remove action. And that action is not executed or performed right now. It just collected to the action queue. So it becomes much more complex when you try to understand how it works under the hood. And you can the most important part, I guess, is to understand that there is this session and it has this persistence context that stores and keep tracks of all the IDs and entities and proxies and other stuff. And also there is this action queue that stores the action that will eventually be transformed into a SQL queries. So this is the track the entity states, and that is to track the SQL queries. And when you fire an event, you actually don't fire event like that. You fire event like this. When you fire an event, what it does, it updates the persistence context. So it changes a lot of different states in the persistence context. And also what it does, it creates an action. That action is collected to the action queue until you call flush on the Hibernate. By default, when you're using Spring Boot and the session is managed by the transaction manager, the flush is called when you commit the transaction. And this word queue is not there by accident. The queue means that all the actions within the queue have some kind of a specific order. And this is the order of the actions. So basically, if you will try to first remove something and then insert something in the scope of the same transaction, Hibernate will do that in the reverse way. First, it will try to insert something and then remove. So this is the Hibernate. It has persistence context, it has action queue, it has dirty checking, flush, cascade operations, orphan removal, lazy loading, and other stuff. And you couldn't even imagine the complexity of the Hibernate if you don't dive into it. But there is always a choice, and in this particular case, the alternative is Spring Data JDBC, which is a new module. It has different philosophy, but what is interesting that it fits into the same place, because if you have the application that relies on the Spring ecosystem, then you're using Spring Data for your data access, and you can easily, well, not easily, but you can replace the Spring Data JPA with Spring Data JDBC and have the completely different experience. So what is Spring Data JDBC? It's a lightweight and simple alternative to JPA. It gets no session, no lazy loading, no dirty checking. We can check out the code, but I guess we can discuss the code of the Spring Data JPA later when we have the next session. When, like, if you're interested more in the Spring Data JPA, JDBC, and its code examples, we can talk about that later. So to summarize about Spring Data JDBC, I can say that it's based on the completely different idea, the aggregate root of the domain-driven design. It still supports the Spring CRUD repository. It supports the native annotation we use. It's straightforward and relatively fast. And if you want to think about which one should you choose, like, so it depends on what you want to do. But first of all, you should learn both a little bit. If you want to go with Hibernate, I really recommend checking out this guy and this very nice book that can teach you a lot about the Hibernate. If you want to try Spring Data JDBC, I encourage you to watch this talk. It's at Spring 1, and this guy is Jeff. He is one of the Spring Data members and one of the authors of Spring Data JDBC. It's based on the domain-driven design, and here is the link to that talk if you want to watch it. And at the end, I just want to say that it's really not about the tools. It's really about the people who use that tools. So tools don't make much difference, but people do. And thank you all very much.
Thank you, Taras. Thank you for the very interesting talk. And I hope, guys, you will join Taras in the Q&A Zoom rooms so he can share more about Spring Data JDBC and show some code, and you will get some practical examples. And if you have any questions, you can write them down to the chat right now, and I will read them to Taras. So we can wait for a minute.
One option what we have is we can try to use the same application we just built and replace the Spring Data JPA with Spring Data JDBC, and we can see how it goes. And but it's more like deep dive, so it's more for people who are like really interested in that.
Yeah, the people in the chat are asking to send the link to the code. Will you be able to share it?
Sure.
Yeah. Okay. Any other questions? The talk was so comprehensive. People are a bit shy to ask questions, probably. Yeah. We have one. What we should avoid eager fetching? When we should avoid, sorry, eager fetching?
I guess generally we should avoid eager fetching. I mean, so like in Hibernate by default, eager fetching is enabled for to-one relations, and it's disabled for too-many relations. And it doesn't mean you should use that. I guess in each specific case, you should try to disable the eager fetching, because the eager fetching actually means that you for sure has that SQL statement even if you don't need it. So I would say that let's try to avoid it, and only in those cases where you really need it, you can, because the most important part is that you cannot override the eager fetching. If you set eager, it will be always eager. You know what I mean? So it's much better to use lazy and then in some cases override it to eager.
Okay. No other questions, so probably people will join the Q&A Zoom rooms. Thank you, Taras. Thank you so much. And guys, I encourage you to register to our partners prizes draw from our gold and platinum partners. So the links are available at your personal page. Yeah. Good luck.